Great, hi everybody. My name is Victor Hwang. This is Bryan and Jen King. And we are working with the Yelp dataset to infer business attention. And basically, we are looking at how many reviews will businesses receive in some amount of time in the future. And the future can be 6 months, 3 months, or just also tomorrow. There's a Yelp dataset challenge right now, so we were provided with 200,000 businesses, 200,000 reviews, 10,000 businesses, and a bunch of user data as well. And just to quickly give a naive solution to this problem right off the bat, this is a heat map showing the visualization of all the reviews in Phoenix, Arizona. This is where the data set originated. And you can kind of see that there are high traffic areas, presumably downtown areas, that have a lot of reviews. So just naively, you can say that given latitude and longitude, you can predict that maybe a business is more likely to have reviews than being somewhere in the suburbs. But our goal is to improve these predictions for number of reviews by adding in other features that we generate from the data.
So some of the features that we looked at, simple ones would have been things like longitude, latitude, so location, the category of the business, whether it's a restaurant or what type of food it might serve. And then we looked at things like temporal data to predict the future reviews. These include the maximum number of reviews in a day, the start date, the duration of the time that the business has been open, whether the business is still open, things like rating, days since last review, number of businesses in a given area. Some of the more complicated things we looked at would be things like user clustering. We ran k-means over a set of features on users. And interestingly, we found a pretty cool breakdown of the users. We did have to apply human interpretable labels to the centers of the clusters, but we found that there are mostly basic users who do maybe 25 reviews. They're relatively new. There are some happy and angry users who sign on, give 1 or 2 reviews that are really high rated or really low rated, and then disappear from the scene. Nobody finds these reviews to be helpful or useful or funny. Then there's long-timers who have been around for about 3 years who have written, on average, maybe 50 reviews. And then there are some super users who have written thousands of reviews. People find them very useful, and these people generally are likely to have stopped reviewing, so either they exhaust their set of businesses that they can review, or maybe they burn out. So we use these, we try to predict using Gaussian mixture models based on location of the users and their distribution to determine whether or not how many of these users of each type, each category, had visited a particular business?
So that's just a list of 1/2 of the features, or 2/3 of the features. The other type of feature we tried to generate was analyzing the raw review text, and we did sentiment analysis to try and count the number of positive and negative sentences about important features that were accumulated over all restaurants. So if cheeseburgers are really popular in Phoenix, then you would presume that if a business has lots of reviews saying positive things about the cheeseburgers, then it'll do really well. And then at the end of this, you'll get an aggregate for the business of all the positive and negative things based on the important features found for the city. And so we added that in as a feature vector as well.
All right, so we took, using the 2 types of features that both Bryan and Victor explained, we took our feature vectors. We had about 640 features. And the first thing we did was try to fit a model and tested that for all of the businesses that were deemed restaurants. So we had about 4,000 restaurants in our data set. And we didn't get great results, so then we decided to do some feature analysis and see if we could cut out some features and improve our results. We tried 2 methods for feature selection. The first is univariate feature selection. So here we're looking at features on an individual basis and looking at how each of them perform, and then just taking the top some percent. In our case, we took the top 25% of features. The other thing we tried was a greedy feature removal. So here we're removing features and looking at how all of the rest do, and greedily removing some set of features at a time until we're left with just some percentage that we want. Again, we removed until we had 25% left. In the end, we saw that some of our best features were the number of reviews that a business had received so far, the maximum number of stars that any review had generated, and some of the votes about the reviews, and the number of users that had logged reviews for any other business in the 1 kilometer radius. So in the end, we took our best model after we tried all the feature removal things, and we generated results with a validation set. We still got about a 55% error on our test, which wasn't great. This pulls out basically 3 businesses from the set of all the ones that we tested, and it shows that we are doing something. So these businesses each have some differing number of reviews, and we can see that using the features we're generating something close to what the review set was. Questions?
Yeah, so, okay, so the comment.